Let's talk about object-oriented programming in C++. So before we talk about classes, let's talk about a more basic concept called structure. So what are structures? Structures are a way to encapsulate a collection of data items, right? Once you define a structure, it becomes a full-fledged type, and we can use it to declare variables. So let's take a look at a definition of a structure. So here you have a keyword called struct followed by the name of the structure that we have chosen. In this case, it happens to be item, right? Then within the curly braces are the collection of variables that make up this structure. We have to remember to put the semicolon here at the end. Now, in this case, the variables or data items that are included in this structure are a string and two doubles. They are name, prod price, and prod quantity, and they basically represent the line item of a receipt. Right after this declaration, struct becomes a new data type. So item is a full-fledged type, just like int or double, and we can use it to declare variables such as this. You have item, which is the data type, and then you have the identifier, right? Another term I want you to learn is something called member variables. So member variables are the individual variables that make up the struct, right? In this case, name, prod price, and prod quantity. Now, once you have defined this struct and you've declared a data type, you can use it and you can access the member variables using a dot notation. So let's take a look at a definition of main that uses structs. So here we have declared a new variable, my item of type item, right? Now you can use uh, member variables on the left hand side of an assignment to initialize them. And like in this case, we initialize them. You can also use member variables on the right hand side, right? With the dot notation. Here I'm updating price with another dollar, right? You can initialize variables using the curly brace notation, very much like you initialize arrays. So here we have a new identifier called special item, which is initialized uh, to three values, which is in the same order of the member variables, right? Okay. Now, structs can also be passed into functions as parameters by value or by reference. So here's a definition of a function where I'm passing is in an item as reference. And within the body, I'm basically giving a printed representation of it. So let's actually try this out in IDE. I have already copied the definition of the struct. I've copied show item, and then I have main here. The only things I've added here, I am calling show item on both on my item and special item. So let's see what it does, right? It actually is what we expected. It prints, gives a visual representation of the two structs. Now let's extend this concept of structs into what are called classes. Now classes contain not only member variables, but they also contain member functions, right? And this forms the core concepts or the core foundation of object-oriented programming. Now, there are two important terms I want you to learn. One is a class, the other is object. So how are these different? Now, class is actually the data type, that we define, the blueprint that we use to define this new type. An object is an instantiation of a class, right? So it is actually the variable that you declare using the data type class. Okay. Now, after we do this, our program, you will notice, will become uh, a bunch of objects that are interacting with each other by calling each other's methods, but more on that later. Let's take a look at a simple class definition. So I've redone my definition of item as a class. It still has its member variables that we have seen earlier, right? And additionally, it includes a member function. Here, the member function is called output. And notice that it is basically a prototype or a declaration. It doesn't really provide the implementation. Now, the last thing you will notice here is this access specifier called public, which basically says that any of the member variables or the member functions are accessible anywhere in the program. We'll learn a few more access specifiers in this lesson and future lessons, but public is the one that we're introducing right now. Now you have this prototype. Now, how do you declare it? Now, or how do you define it? Right. So you implement the member function uh, outside of the class as a separate function definition. This looks very much like a function definition. The only thing you'll notice here is that you have a scope resolution operator here, which has the name of the class and colon colon. This tells the compiler that this output that's being defined is the one that is in item. The other thing you'll notice here is that we are referring to the member variables without the dot notation. That's because the compiler already knows that these variables are the ones within that particular class, right? Once we do this, we can use this class in a main, and this basically would look very similar to a struct where you define something called current item, which is of type item, right? And with this, we have created the object, right? And we can set the member variables. And additionally, we can call the member function again with the dot notation.